Without having the problem, we can try to reconstruct it.
Well, maybe we shouldn't, because I can't.
Okay. Does that ring a bell for anybody? Surplus, short run? Okay. Well, Wednesday we can hit it too. So, I don't even know if it's worthwhile me speculating what it could be. I have an idea of some things I could do, but it could be completely different. So let's just hold off till Wednesday on that one. Okay, anything else? All right, pull out your worksheets then. We had one more, I think, in chapter 8, right? One more of the ones I gave you anyway. Okay, so 8.4. Suppose that the market for cantaloupes is currently in a long-run competitive equilibrium at a price of $3 per melon. A listeria outbreak in cantaloupe crops leads to a sharp decline in the demand for cantaloupes. So part A, in the short run, what will happen to the price of cantaloupe? Explained and used in an illustrated graph with your answer. So, thoughts on how we start this one off? It's asking for a graph. What graph do you think would be a good one to look at? What's that? Home base. Good. That's always a good place to potentially start. And then, so our home base is this picture, I guess, where we got cantaloupe, price of cantaloupe, supply, demand. Let's see if I got another black ink in here. Telling this light, I think that's black. Yeah, that's black. Okay. Now we need more than home base though. So what's the name of this chapter? Perfect competition. So what would be? I totally agree with you. That's part of what we need. The individual representative firm. Good. So draw that. I think the best place to start would be with the two graphs side by side concept here, which is our model of perfect competition, where we've got little q, and so this is our representative firm. Here's the big cantaloupe market. And what would be the appropriate picture to draw for that? For starters. Could even think of it as kind of another home base, or an add-on to home base for perfect competition. I guess I didn't finish up my home base very well, did I? You guys probably did better than I did. Let's see, we got a $3 price. They didn't give us a quantity, right? What's going on over here? Good. So where does it belong? Straight across. The firm is a price taker. So the demand curve equals the marginal revenue curve at the price of $3. Okay, good. I like that. Let's keep going. What else we need according to this problem? What does the problem say, Jesse? Read that first sentence again here.
Suppose the market for cantaloupes is currently long equilibrium at the price of $2 per melon.
Okay, stop there. So, what does that mean? What else would be needed to add into this picture for long-run equilibrium? There's one important piece of the puzzle: long-run equilibrium. What's our predictions in the long run for perfect competition? Profit is 0. Good. So that's one of our long-run equilibrium situations we expect. That's why we're calling it a long-run equilibrium, is that economic profits would be 0. The firms would be earning a normal profit, of course, but economic profit would be 0. So what's missing? Cost curve. Which one? Average total cost. Where does it belong? U-shaped and tangent to this line. Good. So the average total cost curve should look something like that. All right. Any questions on that? So we're going to learn a few pieces to the puzzle. There's really just a couple, probably 3 key things that you need to really just have memorized to solve this stuff out. So this is one of them here. So long run equilibrium would show no profit. How do I know that, what was special about this tangent point? I've got something missing here that's needed. Marginal, what? Cost. Okay. So the marginal cost curve cuts through the minimum point. Now we've got all the pieces that we need to really tell the full story. The full story is that every firm maximizes profits by producing the quantity where the revenue generated by the last unit produced is equal to the cost of the last unit. So where the marginal cost curve intersects the marginal revenue curve is the profit maximizing quantity. If this is a long run situation, then that average total cost curve is just tangent the way we have it drawn, showing that there's no economic profit. Economic profit equals 0. So all of that is the setup for A. We haven't even tackled part A yet, right? So part A says, in the short run, what happens to the price of cantaloupe? Explain using a graph. So what happens? We've got this listeria, which is a bad thing for people who eat cantaloupe. They get real sick. And why is it decreasing? Demand's moving left, right? So there's a decrease in demand at every price. Demand curve shifts to the left, causing price to fall. So we can draw just some demand curve in there. Let's call it, I guess if this is D1, we'll call this D2. And price is going to fall. So in the short run, what will happen to the price of cantaloupe? The price falls. So it looks like we've got part A nailed now. B, in the short run, how will the firm respond to the change in price described in A? What will happen to each producer's profit in the short run? Explain using a graph. So how are producers going to respond? Leave the market. A little too harsh at this point. Because, and why is that a little harsh? Is leaving the market long run or short run reaction? Long run. So leaving the market's a long run deal. So prices fluctuate quite a bit, yeah. So it's possible that we could shut down, which would mean produce nothing. But what do we know for sure that this firm, if this is the quantity they were producing in the long run equilibrium, there's a demand shock, price falls, what do we know for sure, what can we state with certainty is going to happen for the individual firm? They're going to lower, well, yes, price is going to go down. That's determined by the market. So he or she's not really lowering it, but yes, price is going to go down. Going to produce less. That's what I was looking for. So for sure, we know it's going to produce less. Do we know it's going to be a shutdown, though? No. What do we need? What information would we need to know whether we're going to shut down? Okay, we need the new price, and then furthermore, what would we need? Variable cost, right? The shutdown was determined by average variable cost. So we don't have that drawn up here, but if the average variable cost is way up here because there's a lot of fixed cost and price falls here, then we might need to shut down. So the shutdown point was where price and average variable cost were equal to each other. So we don't want to read more into the question than what's here. We haven't been given information on variable cost. All it says is, in the short run, how will firms respond to the price described in A, and what will happen to the producer's profit? So for, what are we on, C or B? B. So for A, we had a decrease in price. For B, we have a decrease in the optimal quantity. So as price falls to P2, whatever that number is, then that is reflected with a new demand curve, D2 and MR2, causing a reduction in the optimal quantity to produce down to Q2. And then what about profits? It says, what will happen to each producer's profit in the short run? Decrease. Good. Now, in fact, we can even be a little bit stronger with that, but that's the most correct statement, is that the profits are going to decrease. And we do have a little bit more information as well. What can you say on top of them decreasing? I totally agree with the decrease, but at this new price, what else do we know about profit? What were they before? 0. What are they now? Something negative. That's all I was looking for. So I was fishing around for that they're negative. So we got a we have a loss going on. So profits are going to be, there's a decrease of profits, and
So that's in the long or the whole market, right?
yeah, this is the representative firm. So now all of the firms are incurring a loss on average. Which then is going to bring us back to Blake's comment here, ultimately, of what's the long run situation going to be, which I assume this is what part C is going to get into. So any other questions or clarifications before we move on to C? Everybody tracking? So part C, given the situation described in B, what can we expect to happen to the number of producers in the cantaloupe industry in the long run? Number of producers is going to, Blake, decrease. So there's going to be a decrease in the number of suppliers, which is due to exit. So in the short run, we can absorb a loss, but if that loss seems to be persistent and we've had our opportunity again in the long run, what was the key distinction between long run and short run? What makes the long run long and the short run short?
There's at least one fixed.
Yes, the fixed variables and not costs, right, but the fixed variables, that the actual physical inputs are fixed in the quantity. So there's at least one variable, one resource fixed in the short run. So in the long run, if this seems to persist, we've tried new machines, we've tried new buildings, we've waited for the market to bounce back, blah, 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 we're going to start exiting. And so as we start to exit, then we've got the price following the new demand curve. Again, if this demand curve stays persistent, then we're going to see an increase in the price. And what does that do to profits? What's happening to profit when people start to exit? They start to go up again. So they were losses. By the way, graphically, I don't know if I want to put them in, but the loss here graphically would go up to the average total cost curve, hang a left, and we were only getting that starts to shrink. Okay, so profits are going to go down. That was a little bonus material because I don't know if that really asked. It just said the number and then Y. And then D, what will the long run price of cantaloupe be? What's that? $3. Okay. So in the long run, people are going to continue to exit until profits go back to 0. So we can kind of predict here that the supply is ultimately going to shift back to here. And the remaining firms are going to be back to 0 profit. Notice how we said the remaining firms, because the industry has taken a big haircut, right? There's not as much quantity being produced anymore, given this new demand curve, but we've had this disequilibrium resolved by having a lower market quantity and firms still, the existing firms, back to what they were producing before. And actually, I should probably put a 3 in here almost, but I don't want to. Part of our story was jumping from Q2 to, let's make that a 3. And then we can kind of change this back to Q3. Okay. So, questions on that? I want you to add one little piece onto this D that is actually not discussed in the answer part either, because I think we either get to it later in the chapter compared to where this one fell in the chapter. But this is for a constant cost industry. So, the answer is 3 if, and this is the if that I want you to add on, if the industry is a constant cost industry. Constant cost industry. Okay, yeah. I'm not sure if he's using that exact language, but it's right here. Huh. Okay. Oh, if I'm reading this right. Oh, there it is. I thought it was in here. Okay. This is covered in section, that's why I wanted to give it to you so you had it down in your notes. Towards the end, page, let me just give you a page number, page 335. And then here's your kind of bonus material. Well, it's not bonus, it's in the book, it's covered, but note there are 2 other cases. One is a decreasing cost industry. Decreasing cost industry. And this is an industry where input costs decrease as the industry expands. So the key point that differentiates this, let me motivate this with a little bit of a story. Let's say that when they started manufacturing cars back in the day, and as we moved through the 40s and the 50s and we started to make more and more automobiles, the unit price of a tire, a rubber tire, might have been pretty expensive relative to the car. But as we started producing more and more cars, the rubber plants and the tire factories could get bigger and bigger, and they could take advantage of economies of scale and lower the cost per tire. Right? So conceptually, as the car industry expands, the price of tires falls. You with me? It's a long-run concept, not a short-run concept, a long-run concept. So as the tire industry, or as the car industry grows, the price of tires fell. So let me give you that little example just to jog your memory here. So the auto industry. As the car industry grows, the price of rubber tires falls. And maybe there's other components to the car, but that would be the idea of a decreasing cost industry. So the key is that this is a long-run concept. Now, graphically, I don't even know if this tells as good of a story graphically here. I kind of don't want to undo this. The average total cost curve shifts down as the supply curve shifts. So it's a long-run concept. There's a shift down, a decrease in average total cost as supply shifts, which means there's entry or exit, but we kind of are telling an entry story here. So as the car industry grows and there's more and more firms entering the market, then there's a decrease in average total cost.
So either way the supply curve fluctuates.
What's that?
No matter which way the supply curve fluctuates, the average total cost can decrease.
No, that's where I kind of thought it was difficult to come back to this, because if the industry is shrinking, then just the opposite happens and costs go back up.
Okay.
So this is where it would get a little ugly, and maybe it's worth showing one picture, unless I can just dump you off to the textbook, which I can't. They just talk about it, they don't show it. All right, I'm going to show you one quickie here. It's not that hard. I think you guys will get this. So just draw just what we did before. In fact, I'm going to be a little sloppy and skip some of the details. So there's the long-run equilibrium. Now let's say that the demand curve shifts up and increases to D2. That causes profits over here. And so if we had drawn everything, there'd be economic profit. Economic profit's going to send a signal out for entry. So where this market is going to head in the long run is back to here. So we started here at P1 and Q1. We went up because of the increase in demand for automobiles. As new cars start to expand in, the supply curve is going to shift down, but this is where I want to show the decreasing cost industry. So instead of coming back to equilibrium, which is what we did over here, with the constant cost, the average total cost curve is going to fall. And so average total cost is going to drop to something less. And just maybe I should have drawn this a little prettier so we don't have to clutter it up with more average total cost. Maybe it drops so that the minimum point is still here. then the supply curve is going to actually fall all the way down here. So as entry occurs, the average cost is falling down. Now you can see why I was trying to avoid drawing the graph, but you asked for it, Jesse. And the next one I'm not going to draw a graph for, but it's the other possibility of an increasing cost industry. So number 2, an increasing cost industry. And so input prices rise as the industry expands. So, for example, maybe we have the wood furniture industry, and an increase in the quantity of furniture in the long run, an expansion of the industry causes an increase in the price of lumber because trees are scarce and we only have a certain amount of trees, and maybe there's circumstances in the lumber market that cause lumber, an important resource, to increase in price. All right, enough on that. Yes. Yeah. Both of these are all long run. Think about that industry. And then I guess we might as well put the average total cost curve shifts up when there's an increase in supply. All right. Couple things that I think before we leave this chapter, after flipping through the pages, I think we talked about this, but with that whole representative firm stuff, just maybe some last remarks on supply. So the industry supply curve. Some kind of, I guess, bullet points. First, hopefully you're all comfortable now that the marginal cost curve is the supply curve for prices greater than average variable cost. So as long as we're not at a point where we need to shut down, the marginal cost curve is the supply curve. The market supply curve, so the market supply, the QS for the market, is equal to the sum of the little QS's for all n firms. So if this is the quantity supplied by firm I, and there's 100 firms, we just add up the supply for each firm. This is very similar, basically the same concept as we saw in demand. It's the horizontal sum of individual supply curves. At each price. And we had that one exercise that we went through with the low cost producer and the high cost producer that was addressing that. So let's take a look, unless there's any other questions, at our next chapter, which is the other end of our spectrum, monopoly. And of course, we'll go through some problems on Wednesday with your homework. Oh, by the way, I have your homework for number 7 up here too. So suppose there's a demand curve that looks like the one we got there, 12.5 minus 0.5p. What is the marginal revenue curve that corresponds to this demand curve? Calculate marginal revenue when it's equal to 6 and 7. So, monopoly. Do we got a price taker? No, we have a price maker. So the monopolist faces the whole demand curve rather than having to share it with anybody. For what reason? Why do they have this luxury of facing the whole demand curve? One producer, why? That's true. That's kind of by definition, there's one producer. What's the barriers to entry? So there's some sort of barriers to entry is what's giving this firm that advantage. And so now we've got the whole demand curve in this problem. And we need to calculate the marginal revenue. For the price taker in the competitive situation, the marginal revenue was equal to the demand curve, or the price, right? So marginal revenue equal price. So with monopoly, we've got 3 characteristics that I like to just kind of review. Helps us keep our brains in order. Instead of many sellers, we got one seller, as you said. We have a homogeneous product, which is just like we did in perfect competition. But the reason we have a homogeneous product here is that we just have one firm, one product. So this is a single product firm, by the way. Later we can talk about multi-product firms where they have multiple products. But this firm is just producing one product, and therefore it's a homogeneous product. And we have the barriers to entry. In principles class, we learned that that could come from patents and maybe some super high cost of getting in. Maybe if we're talking about drugs, it's the fact that you lose your life or your family's life is at stake, right? We learned that in the Freakonomics book. So who knows? There's some sort of barriers to entry to keeping people in the market. What did that cause the marginal revenue curve to look like graphically? Does anybody remember the trick that we had in principles class to with the downward sloping demand curve, and I don't know if you were referring more to the slope, Blake, or not, but there's the elastic portion and the inelastic portion. So the elasticity changes along the demand curve. What did you mean by inelastic? There is, I have a feeling I might know it, but I don't want to put words in your mouth. What did that marginal revenue curve look like?
Is this the graph where we do the graph underneath it with the
Yep, can. If that helps you. We had this, this, this. This is total revenue. This would have lined up perfectly there if I would have drawn it really carefully. The total revenues are maximized at an elasticity that's what? 1, unitary elastic. Then we had the elastic range, the inelastic range. That's not really the question I'm asking, but it is related to what I want you to draw. What does the marginal revenue curve look like for a single product firm? What's that? No. Under some special circumstances it does, though. So I'm just going to kind of show you ahead of time. Demand does equal marginal revenue if the firm can do that. In perfect competition, when we had, I don't remember what example, well, we just had this melon example. So what was the revenue generated by an additional melon for a representative firm in perfect competition? The price. $3, the price, right? So whether that was the 101st melon, the 121st melon, or the 1000th melon, it was $3, $3, $3, $3. Price equaled marginal revenue.
Is it the one where it like breaks off from the demand curve?
Yes, it's the one that breaks off. How did it break off? Let me go back to cheating on this little example here. Let's just say 1, 2, 3. And this is at $9, $8, and $7. And this is at 10. The revenue generated by the first unit is 9, right? The revenue generated by the first unit is 9. The revenue generated by the second unit is, be careful, the price of the second unit is, that one should be easy, 8. The revenue generated by the second unit is 7. Okay? So the price of the second unit is 8, but the revenue generated by it is only 7. Why? First unit and second unit. So we're going to sell both units for 8, which means I really gave up $1 on this unit, but then I gained $8 on the next. So the revenue generated by it was 7. Think of it this way. Total revenue associated with producing 1 unit is $9. Total revenue with producing 2 units is 16, 2 times 8, which makes marginal revenue $7. So the revenue generated by the second unit is $7, and then it looks like that. I'm just going to give you the abbreviated version. What's the revenue generated by this unit right here in this graph, since Jesse brought up the elasticity? What's the revenue generated by this unit right there? 0. So the revenue generated by that unit is this dot. In other words, it's 0. And so that was the trick that we did. This was, again, nothing that you didn't see in principles. If you take the bisection point of where the demand curve intersects the horizontal axis, take the midpoint, there's a marginal revenue curve that falls right through that and goes negative. So yes, that's what you're saying, Blake, with the separation of marginal revenue and demand. That's the picture that we got. How does the slope of the marginal revenue curve compare to the slope of the demand curve? How does the slope of the marginal revenue curve compare to the demand curve? Nope, not inverses. Let's just say that this slope is 1. What do you think this slope would be? Half. This is half the distance, making this steeper or flatter? Steeper, so the slope is double. There you go, the other direction. So you guys were all on this inverse path. But the slope of the marginal revenue curve is twice as steep. So MR is twice the slope. And that's going to come in handy when we do the equations. So that's why I'm putting a little more emphasis on it here. Marginal revenue is twice the slope of the demand curve. And that's probably a good spot to jump into this problem. So for this problem, we have a demand curve of Q equals 12.5 minus 0.25 P. And this is demand curve, so we can think quantity demanded, but it's Q. Oh, sorry, Colby. So make this problem with this equation match the logic of what we did graphically. A graph is not required for this problem, by the way. But make the logic of what we did here work with this equation. If we were to take this and graph it, would it look like this exactly the way I've got things set up? If I take this equation exactly the way it's written here, would I get this graph? No. What do I need to do? Inverse. Good. Remember that? We haven't done that for a little while. So we need to find the inverse demand curve. So go ahead and start there, which means we're solving for P. What did you guys get? Not bad. Good. Glad somebody was brave right away. Jumped out. What'd you get? 50. Yes. So, kind of forgot about my 0.5s there. All right, so 50, 12 and a half is 25. 25 times 2 is 50. So, you got that? Okay. Not the minus 4q. What happened there? Anybody else? What'd you guys get? You got that? Taylor, what'd you get? Negative 0.25. You got? So 1, but you got it now? You got 4? Okay. Everybody get 4? So sometimes, I mean, you got a 1 over here. 1 divided by 0.25 is 4. This is where I think sometimes it's easier to convert it back to fractions, right? So if you had a 4th over here, we're taking that 4th. 4 times 12.5 is 50. 4 times q. So be careful with that stuff as you work through. All right, so back to our question here. What is the marginal revenue curve that corresponds to this demand curve? How would you do that? 50 minus 8q. Good. So we're just going to take twice. We're going to use that little trick here graphically that this is twice the slope. And that's going to become our marginal revenue curve. So our marginal revenue is equal to 50 minus 2 times 4q, which is just simply 8q. So just to show all the steps here on the first go around. So now we've got that marginal revenue curve. Now part B, what about when q equals 6, q equals 7? So solve for part B. If q equals 6, marginal revenue equals 2. Good. Right. 8 times 6 is 48. 50 minus 48 equals 2. And if q equals 7, marginal revenue equals negative 6. Is it okay to be negative, or did we screw up? It's okay to be negative. So that's this part, mapping up the graph at a quantity of whatever. In this case, it was 7. Again, this isn't drawn to scale. Then the marginal revenue was actually a negative 6. And that's exactly the same story we learned with the elasticity relationship, which is we're going to come back to in advanced pricing. So again, this section here is the inelastic portion of demand. And if we cut price when demand is inelastic, then that leads to a decrease in revenues. In other words, the marginal revenue, the additional revenue associated with a price cut when demand is inelastic, is a negative amount of money. So yeah, that all works in harmony together. Okay. That wraps up that 9.1. Let's call it a day there. So you got the chapter problems.
Chapter 8, right?
Chapter 8. Back to the chapter homework problems. Yep.
And then you said start probably. Or what is it?
Yes. Chapters 8.
Eight.
I don't know, 7 and 8 keep going in my brain.